Welcome back, everybody, for another deep dive. This time we're exploring the world of soft robotics.
Sounds squishy.
It really does. We'll be looking at how this field is really kind of changing how we think about, robots and building machines. Imagine robots that could squeeze through those really tight spaces
Yeah.
like an octopus can, or handle a delicate flower without just totally crushing it. It might sound like something straight out of science fiction,
Yeah.
but it's all thanks to those incredible properties of polymers and gels.
Right.
And we learned all about this from Cocktail Party Chemistry's episode 130.
Yeah. Unlike those rigid metallic robots
Uh-huh.
that we see all the time in movies and stuff.
Right.
Soft robotics really takes its cues from nature.
Oh, that's so cool.
Yeah, think about how a chameleon just effortlessly blends into its surrounding.
Right.
It just changes its skin color. And soft robots can actually do that same kind of thing.
Wow.
They can mimic the adaptability, which makes them so ideal for navigating, those super complex
Yeah.
and unpredictable environments.
Okay, yeah, that makes total sense. But so how do polymers and gels, how do they actually work
Right.
to create this flexibility? Are we talking about a super advanced version of silly putty?
Well, you're not totally off base there.
Oh.
Polymers and gels, they have this unique ability to deform and then return to their original shape,
Okay.
which gives them that flexibility that you were just talking about.
Gotcha.
And they're made up of these long chains of molecules that can stretch and move,
Okay.
almost like a tangled up mess of spaghetti.
So you're telling me robots are being built out of microscopic spaghetti.
That's where the magic is.
That's wild. But okay, so then how do you actually control something that's essentially, squishy?
It's a fascinating challenge.
Yeah.
One of the biggest breakthroughs in soft robotics has been developing these responsive materials.
Okay.
So these are polymers and gels that are designed to change their properties in response to external stimuli.
Interesting.
So things like temperature or light or even pressure.
Oh, so you're saying that we can essentially program these materials to react exactly to their
create-
environment?
Imagine a soft robot that's designed for a search and rescue mission.
Okay.
It could squeeze through narrow openings by becoming more fluid, and then it could stiffen up on demand
Wow.
to provide support or lift debris.
So it can change its...
It's this responsiveness
Oh, wow.
that really sets soft robotics apart.
That's impressive. So how do scientists even begin to design materials with such specific responses?
It all comes down to the chemical structure.
Okay.
So by tweaking the arrangement and types of molecules in the polymer chains, we can fine-tune their properties.
Oh, that's cool.
Do you want a material that's super elastic, like a rubber band?
Oh, yeah.
Or one that's more viscous, like honey? It's all about manipulating the chemistry.
So it sounds like building with polymers and gels is almost like having this molecular toolbox, and you're choosing the right tool for the job.
Yeah.
But I'm still curious about, how do we control these robots in real time?
Right.
Traditional robots have all those gears and motors and things. But how do you direct something that's basically a blob of responsive material?
That's where things get really interesting.
Okay.
We use sensors. By integrating sensors directly into the soft robot structure, we can give it a sense of its surroundings.
Okay.
These sensors can detect things like pressure,
Yeah.
temperature, and even chemical changes.
So it's almost like giving the robot a sense of touch.
Exactly. That sensory input is then used to control the robot's movements.
Gotcha.
For example, a soft robotic gripper could use pressure sensors in its fingers to adjust its grip strength so that it doesn't damage delicate objects.
Okay, so I'm starting to see how all these pieces fit together.
Right.
You've got these amazing materials that can adapt and respond, and then you add in the sensors for the real-time control.
Right.
It's like a whole new way of thinking about robotics.
It is. It's a real departure from those traditional rigid machines that we're used to.
Right, right.
And this new approach is what makes soft robotics so exciting.
Yeah.
It's opening up possibilities in fields ranging from medicine to manufacturing.
Oh, wow.
But to get a better picture of that, we should probably move on to some specific applications.
Okay, let's dive into that. I'm particularly interested in how soft robotics is changing the landscape of healthcare.
Okay, well, imagine a world where surgery is minimally invasive
Yeah,
and they're using these tiny, flexible robots
okay.
that navigate through the human body with incredible precision.
Oh, that sounds like straight out of a sci-fi movie. But you're saying it's actually becoming a reality.
Absolutely. With soft robotics, we can develop surgical tools that are so much gentler on tissues and organs,
Okay.
which leads to faster healing times and a smaller risk of complications. These robots can even get to areas that traditional surgical instruments just can't reach.
That's amazing. I can also see how soft robots could really change the game for people with disabilities.
You're thinking of prosthetics?
Yeah.
You're right on the mark. Soft robotics allows us to create these prosthetic limbs
Mm-hmm.
that are way more comfortable and lifelike.
Right.
These prosthetics can even incorporate those sensors
Yeah.
to provide feedback to the user so they can mimic the sensations of a natural limb.
That's incredible. It sounds like soft robotics is revolutionizing how we think about, treating injuries and improving people's quality of life.
Right.
What other applications are there? I know you mentioned manufacturing earlier.
Yes. Think about all those delicate tasks that you see in factories,
Yeah.
like handling fragile components or assembling intricate electronics.
Okay.
Soft robots are perfect for these jobs
Yeah.
because they can adapt to the shape of the object and apply just the right amount of pressure.
So it's like having a robotic worker, but with this delicate touch. Like a master craftsman.
They can work alongside humans safely and efficiently,
Mm-hmm.
even in those confined spaces.
Okay.
This is really leading to a whole new wave of automation that's more collaborative and adaptable than we've ever seen before.
And what about using soft robots in, like, say, search and rescue missions?
Yeah,
I feel like their flexibility would be perfect for, like, navigating debris.
you're right.
Yeah.
Soft robots can maneuver through those really tight spaces
Mhm.
and over uneven terrain way easier than their rigid counterparts.
Right.
Imagine a robot that can squeeze through a collapsed building to find survivors.
Yeah.
Or one that can adapt its shape to grab and move that heavy rubble.
Wow, it sounds like soft robotics has the potential to save lives
It does.
in some really challenging situations.
Mm-hmm.
So, like, what are some of the hurdles that scientists are facing in this field? Is it all smooth sailing from here, or are there still challenges to overcome?
Oh, there are definitely challenges.
Right.
One of the biggest ones is durability. These soft materials, while flexible,
Yeah,
they're still susceptible to wear and tear.
right.
So researchers are constantly trying to develop these tougher, more resilient polymers and gels
Okay.
that can withstand, all the rigors of real-world applications.
So it's like a balancing act
Yeah.
between, maintaining the flexibility and then also making sure that the robot can actually handle, like, the demands of its job.
Precisely. And then there's the question of control. As
Right.
we talked about earlier, controlling a soft robot is so different from controlling a traditional rigid robot.
Mm-hmm.
So researchers are still working on developing algorithms and control systems that can account for all the, unique ways that these soft robots move and interact with their environment.
It sounds like such a complex dance between materials, science and engineering, and computer science.
It really is a multidisciplinary field,
Yeah.
and that's part of what makes it so fascinating is bringing together all these experts from these different areas
Right.
just to push the boundaries of what's possible.
Totally.
But, one thing that really struck me from the cocktail party chemistry episode was how scientists are drawing inspiration from nature
Uh-huh.
to try to overcome these challenges.
You mean the biomimicry we talked about earlier?
Yeah.
I'm really intrigued by that whole concept.
It's incredible. Think about how an octopus can change its shape to fit through tiny spaces,
Okay.
or how a gecko can climb walls with its specialized feet.
Right.
Nature has already solved so many of the problems that we're facing in soft robotics.
Right.
So by studying biological systems, we can find elegant and efficient solutions.
So it's like nature's providing this blueprint for innovation.
Exactly. And this bio-inspired approach
Yeah.
is leading to some really cool developments. For example, researchers have developed these soft robotic grippers that mimic the way a chameleon's tongue wraps around its prey.
Oh, that's so cool. And I bet those bio-inspired designs are helping to address those durability and control challenges that we were talking about.
Absolutely. Nature has had millions of years to perfect these designs,
Yeah.
so it makes sense to learn from the best.
It's amazing to think about the possibilities. We've talked about medicine manufacturing, search and rescue.
Right.
What other fields could be impacted by soft robotics?
Well, one area that has a lot of potential is exploration,
Okay.
particularly in those harsh environments like space or the deep sea.
Yeah.
Soft robots could navigate complex terrain, adapt to those unpredictable conditions, and even interact with delicate ecosystems without, causing any harm.
Wow. It seems like the only limit to the applications of soft robotics is our own imagination.
Pretty much.
But with all this talk about this cutting-edge technology,
Yeah.
I can't help but wonder about accessibility.
Okay.
Is this just something for, big universities and corporations,
Right.
or can everyday people get involved in soft robotics? That's a great question. It can feel like all this cutting-edge tech is only for those folks with, like, tons of resources.
Yeah.
But from what I heard on Cocktail Party Chemistry, it doesn't seem like that's really the case with soft robotics.
You're absolutely right.
Yeah.
There's a real push to make soft robotics way more accessible to like everybody.
Okay.
And one way this is happening is by developing these open source hardware and software platforms.
So it's kind of like that open source movement we see with, like, software development,
Exactly.
but for building actual robots.
These platforms actually provide designs and instructions, even kits,
Wow.
that allow like anyone with an interest in robotics to
Okay.
just start building their own soft robots.
So you don't need $1 million lab to get started.
Nope.
What kind of resources are out there for people that want to, like, jump in and experiment?
Well, there's the Soft Robotics Toolkit
Okay.
that was developed at Harvard.
Uh-huh.
It's a fantastic resource. It breaks down complex concepts into like really easy to understand pieces.
Okay.
You can learn about the materials, the
Mm.
fabrication techniques, how to actually control these robots.
Wow.
It's all right there.
That sounds like a great place to start.
Yeah.
And I bet there are, like, online communities
Oh,
where
yeah.
people can share their creations and stuff and, like, learn from each other.
You're right. Places like the Soft Robotics Wiki
Okay.
serve as like a hub for collaboration.
Oh, cool.
People share designs, tutorials, troubleshoot problems together.
That's
It's
awesome.
a super vibrant and supportive community.
I love that. It's really inspiring to see how that open source approach is, like, democratizing technology. It's giving everyone a chance to, like, actually participate in this really exciting field.
Yeah.
We've talked a lot about mimicking nature and soft robotics,
Right.
but what about the ultimate biological machine,
Uh-huh.
the human body?
Okay.
Are there lessons that we can learn from, like, our own biology to advance this field?
What a fascinating question. And the answer is like a huge yes.
Oh, cool.
The human body is a total marvel of soft robotics in itself.
Okay.
Think about like the interplay of muscles and tendons and skin
All right.
all working together
Mhm.
so that we can move with such precision and grace.
It's true. We often take for granted just how complex our own bodies are.
Absolutely. Researchers are studying human biomechanics like super in depth
Okay.
to try to unlock the secrets of our movement and then apply those principles to soft robotics.
Interesting.
Like, for instance, understanding how our muscles contract and relax
Mhm.
could lead to developing more efficient and lifelike actuators for these robots.
So in a way, we're looking to ourselves for inspiration on how to build better robots.
Exactly. And it's not just about muscles.
Yeah.
Our skin is a crazy sensitive organ,
Right.
constantly giving us feedback about what's around us.
Mhm.
So by incorporating similar sensing capabilities into soft robots,
Yeah.
we can make them more aware of their environment
Okay.
and better able to interact with the world in like a more nuanced way.
It's incredible to think about the possibilities. We could have robots with a sense of touch that's as refined as our own.
Exactly.
And with that kind of sensitivity,
Mm-hmm.
the potential applications in fields like healthcare or manufacturing are pretty mind-blowing.
It really is a frontier full of potential.
Yeah.
As we keep unraveling those mysteries of human biology, who knows what breakthroughs are out there that could really enhance the capabilities of soft robots.
Right.
It's like this continuous feedback loop between science and nature.
This has been such an awesome deep dive into the world of soft robotics.
It really has.
We've covered so much ground, from, like, the basics of polymers and gels
Yeah.
to all those, like, mind-boggling potential applications.
It's pretty cool.
It's clear that this technology is going to reshape our world in some really big ways.
It is.
It has been so great exploring these concepts with you.
Likewise.
And with the dedication of researchers and this growing open source community, the future of soft robotics is looking super bright.
Absolutely.
And to you, our listener, we hope this deep dive has sparked your own curiosity about soft robotics.
Mm-hmm.
Maybe you'll even be inspired to tinker with some of those open source design, or,
Right.
like, delve deeper into the research.
Yeah.
This field is so ripe with opportunity, and who knows, maybe you'll be the one to unlock the next big breakthrough.
It could be you.
Until next time, stay curious. Hotel 1279 Mil.